Hello, my name is Víctor Suárez Paniagua, and I'm going to present our participation in the Medical Documents Professions Recognition Shared Task with the work BERT and approximate stream matching for automatic recognition and normalization of professions in Spanish medical documents. The authors of this work are NLP researchers working in the Clinical Natural Language Processing Research Group at University of Edinburgh. The clinical NLP team is multidisciplinary and includes medical, epidemiological, and NLP researchers. Recently, our group has been focused on identifying stroke phenotypes from cerebrovascular radiology reports as well as rare disease identification from electronic health records. In this presentation, I will cover a quick summary of the task, the data and its preprocessing, explaining the proposed Named Entity Recognition system, discuss the results, and show our conclusions. The MEDDOPROF task is a Named Entity Recognition and Normalization task, focused on the extraction of professions from Spanish medical documents. It consists in three different subtasks. The first one is the classification of occupation mentions and include the classes of profession, employment, the status, and activity. The second subtask is the recognition of the person who the occupation is referring to, such as the patient, the healthcare professional, a family member, or to someone else. Finally, the third task is the normalization of each mention to one of the valid codes from an official list provided by the organizer of the task. The annotation contains almost 2,000 Spanish clinical cases from 20 different specialties. The data preprocessing includes transforming the documents into lowercase, replacing special characters by white spaces, tokenizing the sentences by the Spanish pipeline of SPICY, and encoding the entities with the BIOS encoding. In those cases that the documents are greater than 512 tokens, we split them until reach this number, because our system has this limit of tokens. In addition, we overlap some nested entities taking only the longest mention. Additionally, to deal with the multi-type entities, we followed a multi-classification where we have one classifier per class. This picture shows the complete system we implemented for the task 1 and 2, which are the Named Entity Recognition tasks. As you can see, there are different classifiers that generate predictions, and then we merge all of them to create the final predictions over each document. Using the multi-classifier approach, we can fine-tune each model independently and taking the best performance over the validation set. We trained the models for 8 epochs, using a split of 80% for training and 20% for validation. We called BETO plus all to the system that uses all the training set for training. However, we observed that the performance was 0% for the low representative classes. So we decided to include the documents that contain only positive examples for training set, as we refer as BETO plus positive. Moreover, the BETO plus prof NAR model includes the training and validation sets from a previous task, the prof NAR task. For the normalization of professions, we take the most similar professions from the provided list of valid codes using the Damerol-Levenstein distance. The following table shows that the best results for almost all the classes and the overall performance in task 1 were obtained by the BETO approach using only positive examples. In task 2, the BETO approach with all the dataset for training obtained the best results in F1 measure. Finally, we used the outputs from some of the previous approaches to compare them with the list of valid codes, and the best performance was obtained with the BETO plus positive predictions of the task 1. We conclude that the models that use the complete dataset obtain the best precision, while the models that use only the positive examples have the best recall. the approximate stream matching approach obtains a performance of 70% in F1 measure, but we would like to include some preprocessing such as removing stop words, lemmatization, or stemming to compare each profession accurately. As a future work, we want to explore different combinations of BETO classifier with different configurations and merge their predictions. Thank you for your attention, and please don't hesitate to send us an email if you have any question.